Hello everyone, I'm Dr. N. Today I would like to introduce the neural style transfer. Neural style transfer is the task of changing the style of an image in one domain to the style of an image in another domain using deep neural network models. For example, if you take a photo of a night sky, you can convert that photo to a Van Gogh Starry Night format. Won't that be cool? In neural style transfer, we usually have two images, a style image and a content image. We need to copy the style from the style image and apply it to the content image. In this tutorial, we are going to utilize pystiche, a cool library to do neural style transfer tasks. First, you need to install the pystiche module, and you can use the pip install to install the module. It's a quite small module, so it only takes several seconds to download and install the module. And then you need to import both the pystiche module as well as a few other modules to facilitate your work. The first step to the neural style transfer is to get the multi-layer encoder. So the multi-layer encoder includes both the model architecture as well as the pre-trained weights. And here we are going to follow the original neural style transfer paper to utilize the VGG19 model. You can optionally print the encoder to take a look of its architecture. And basically, if you scroll that, you will see it is indeed the original VGG19 model architecture. So the core components of every neural style transfer are the content loss and the style loss. And we combine both of them to make up the overall loss, which is called the perceptual loss. And the perceptual loss is going to serve as our optimization criterion. We can use the feature reconstruction loss as the content loss using the pystiche library. So here we first extract the content encoder that generates encoding from the content layer. And then together with the content weight, we can construct the content loss. So here in the very first step, we extract the content layer from the multi-layer encoder. We can use the convenient extract encoder function to do that. And after that, we can specify the content weight and construct a content loss. So here, following the pystiche library, we use content weight equals 1, but later on you can experiment with different weights. And then we utilize the feature reconstruction loss to create the content loss function. And then optionally, you can print out the content loss function to make sure that it utilizes the layer that you specify and also the VGG19 architecture. And the second step is to specify the style weight, the style layers, and the style loss. So here we assign style weight equals 1000, again following the tutorial provided by pystiche, but you can also change the style weight to see what is the impact of that on your generated image. And then you can specify the style layers. Here we specify a total of 5 layers from the VGG19 model. And then let's construct a style loss. First, we use the gram loss function to create the style loss for a single layer. And as you can see, we wrap it the gram loss in a function where the two arguments for the function, one is the encoder itself, another is the layer weight. So, because we use multiple style layers, then we should create multiple style losses, and we can conveniently bundle them together using the multi-layer encoding loss function. So here is how we do that. We specify the multi-layer encoder. We provide the style layers and also the previous loss function we created together with style weight. You can optionally print out the style loss function. And after we created the style loss and content loss, before we combine them into the perceptual loss, the overall loss, we want to utilize GPU in our computation. So therefore, you should check whether GPU is available. And here I set device equal to the q.gpa if the q.gp is available. Otherwise, we'll just use CPU for computation. And now let's define the perceptual loss, which combines the content loss and the style loss. We use the convenient loss function, perpetual loss, and then you simply need to provide the content loss and the style that you defined. But remember that whenever you have GPU available, you want to put that perceptual loss into your GPU so that you can utilize the GPU computation power, which can greatly accelerate your computation progress. You can optionally print out the perceptual loss, and as you can see, the perceptual loss is a combination of the content loss as well as the style loss. Now let's test it out. First, you want to mount your Google Drive to Colab so that you can use your photos and paintings that you stored in the Google Drive for the NeuroStyle transfer task. So here I mount my Google Drive to Google Colab. You need to provide permissions in order for Google Colab to access your Google Drive. Then first, let's read the content image file using the convenient read image function provided by pystiche. And I downloaded this image from the following web link. So take a look of the image using the show image function also provided by pystiche. And as you can see, it is an image of the Thames River with the Big Bang. And we'll title that image content image. And now we also need the style image. So here, instead of using the Van Gogh painting, I use one of the Claude Monet's painting. I downloaded this image from Wikipedia. Again, we use the read image function to read that image into our Google Colab. And we use the show image function to take a look of that image by Claude Monet. Some of you might be familiar with this image. We'll title it style image. And then we need to set the content image as well as the style image as targets for the optimization criterion, namely the perceptual loss. We simply need to use the function set content image and set style image to do so. At the last preliminary step, we create the input image. We can either start from the content image or starting from random data to create the input image. Usually, we want to start from the content image because this way, the NeuroStyle transfer converges quickly. But if you want to start from a white noise image instead, you can specify starting point equals random. So here, I'm using the content image as a starting point. So I set starting point equals content. And then I use the function getInputImage to prepare the content image as the input image for the optimization problem. And now we can do the final and the most exciting step, which is to minimize the perceptual loss using backpropagation so that we can get the optimal values for our parameter so that we can generate a output image. And here we use the image optimization function from pystiche, and we provide the input image, we provide the perceptual loss function. We also need to specify the number of steps we want to take, basically the number of iterations we want the model to run. So in each step or iteration, the perceptual loss is calculated and then back-propagated to each pixel of the input image. And now let's show the output image after the model runs using the neural style transfer. We still use the show image function and then provide the output image. You can also provide a title as an option. As you can see, our previous photo on the Thames River with Big Bang has been transferred using the Monet's painting, and now the photo has a style of Monet. I'm encouraging you to use your own image to try out this very cool neural style transfer package. Thank you so much for your attention, and I'll see you next time.